For more illustration, if I have this triangle here, and this triangle I name it as A, B, then C. I call here gamma, I call here alpha, and I call here beta. The line A here, it has a relationship with other sides of the triangle. According to the cosine rule, the length of A, it is given as A squared is equal to the square of the other sides of the triangle, which is B squared plus C squared, then minus 2 times those other two sides of the triangle, which is B times C in this case, then cos the angle that A subtends at the other side. When we take A, the length A, this part, it subtends an angle here, which is at the alpha. So cos the angle it subtends, which is alpha. In the same way, if I'm looking for B, then I'm having B squared is equal to A squared plus C squared minus 2 times the other sides of the triangle, which is A times C cos beta, and the last one too. So this is a brief of the cosine rule. So when we look at this one, we can say that the Pythagoras theorem is a special case of the cosine rule. Assume one side of the triangle. When we have an angle of 90 degrees here, then it means that, assume I have A here, B here, and C here. We know that cos 90 is always equal to 0. So if the angle alpha, beta, or gamma, if any of that is equal to 90 degrees, then this part of the cosine rule will disappear. Then the formula will be modified to the Pythagoras theorem, which states that the hypotenuse squared is equal to the adjacent squared plus opposite squared, which is, in this case, you are getting A squared plus B squared is equal to C squared, because this part will be equal to 0. The same way for the C part, the whole of this part will be equal to 0 if the angle here is 90 degrees. So we can say that the Pythagoras theorem is a special case of the cosine rule. On the other hand, the sine rule, as we have said earlier, is given as A over the sine of that side, the angle the side subtend, which is alpha. This is equal to B over the sine it subtends, which is beta, and it is also the same as C over the sine that it subtends, which is gamma.